Hello guys, this is today's extra skills review. We're going to go through a problem around area. So today we're going to do just one problem. It says find the area of this irregular heptagon. A heptagon, by the way, is a seven-sided shape, and technically that's exactly what this is. There are seven sides to this shape, and I'm calling it irregular because this is not a regular looking shape. It's kind of unusual. So an irregular heptagon. So ultimately, guys, what we want to do is we want to find the area of this, which people want to find out like how many square units would fit inside of this. And we could, if we wanted to, like go ahead and decompose this like crazy. And actually, I'm going to lock this in place first. And let me show you what I mean by that. So if I wanted to like decompose this shape, I could go ahead and I could split it up into a whole bunch of different shapes. So if I like drew a line right here, and then I drew a line that kind of continues right here. And then I go ahead and let's see. Well, we could go another one like right straight up like this. Let me slide that over a little bit and we might actually have it. So there we go. Like, hey, there it is. We could split this shape up into a rectangle, a triangle, and a triangle and find the area of all four sections. And we could add those areas together, and that will give us the area of this irregular heptagon. But I hope that you guys see that there's actually a much simpler solution to this problem. So for this one, guys, I don't know if you guys agree with me, but this to me looks like it was a rectangle, but then a triangle was more or less cut and taken from it or subtracted from it. And so that's how I'm going to treat this problem. I'm going to go ahead and pretend that the whole rectangle is there. In fact, I'm going to go ahead and draw that rectangle right now just so you know exactly what I'm talking about. So if you look at it like this right here would be the whole rectangle. And then you can tell that a triangle was more or less removed from it. So what we're going to do first is we're going to find the area of that rectangle, and since there's no grid behind it, we need to actually do some measuring. So the rectangle is simple. We need to measure this length and we need to measure this width, and we'll get the area of it. So if I go like so, we can see that this length down in the bottom here is 9 centimeters long. And I'll label that right there. And now we'll go ahead and we'll rotate our ruler because we have to also measure the width. So let's go ahead on up here, and if I put that there, you can see that that width ends up being 4 centimeters. Okay, so let me go ahead and label that over here, 4 centimeters. And so now it's simple. The rectangle, if we wanted, I'll even put that down here. The rectangle, the area of it equals 4 times 9 equals 36. And since we measure with centimeters, the area would be square centimeters. So that's what we know so far. And I'll even put that up here. But we're not trying to find the area of a rectangle. We're trying to find the area of that irregular heptagon that we started with. And so I need to more or less find the area of this triangle and then take it away from the 36 square centimeters that was the rectangle. So what I'm going to do, and I mean, there's lots of ways to find the area of a triangle. We've talked about base times height divided by 2, but I still like to talk about, a triangle is half of a rectangle. And so what I'm going to do is I'm going to go ahead and put that triangle into a rectangle, just like I had mentioned earlier. So give me a second here. Go ahead and make it a different color. And all right, so I'm going to take this triangle and put it inside this rectangle, just like that. So now if I find the area of that rectangle, then I know this triangle will be half of that. So let's go ahead and let's do that. So the area of this rectangle, I need to measure, gives us, well, that's 3 centimeters. I'll label that. Don't get too confused by all my measurements. So that's 3 centimeters. And then let's go ahead and let's measure this other one over here. If we look, then that's also 3 centimeters. So turns out if it's a 3 centimeter by 3 centimeter, that's a special kind of rectangle that makes it a square. So here we go. So in this situation, we just found out that this red rectangle is a 3 by 3 rectangle, which means the area of that rectangle is 9 square centimeters. So in this situation, we know that this triangle is going to be half of that, half of the 9 square centimeters, and half of 9 is 4.5 square centimeters. So let me label that down. Let's drag this down here. So the large rectangle was 36 square centimeters, and then the triangle that has been removed from it is 4.5 square centimeters. So now our final step is simply to go ahead and use that bit of information. We said that that heptagon looked like a rectangle that had had a triangle taken away from it. And so now we need to actually do that subtraction. So the heptagon is going to be equal to 36 square centimeters minus 4.5 square centimeters. And for a final answer there, if we have 36, if we take 36 and subtract 4, that gets to 32. And then if I subtract a half from there, that gives us 31.5 square centimeters. So it's one of those key things. We have not done a problem like this before, but it's important to remember that area, it can be additive, which means like if we want, we can split something up into a whole bunch of pieces and then add those areas together. But we can also be subtractive with it. Like we can look at something and we can find an area that's actually larger than the shape, but then subtract to find the area of the shape we're looking for. I hope you guys found this problem interesting, and I hope you guys have had a great week.